Okay, so this video is going to take you through how to perform different operations on polynomials. So to start off, I give you these three polynomials at the top, and we're just going to go through a couple different things we can do with them. So the first question asks you to find p of x plus q of x. So all that means is that you're just going to take your two functions, or your two polynomials, keeping them both in parentheses so that you can keep them separate. And plus 3x squared plus 4. And as you would probably expect, all you're really doing is combining like terms. With addition, we don't change any signs, we don't do anything fancy. To keep my answer in what's called standard form, I always put the highest exponent first. So since x cubed doesn't have anybody to combine with, I'm going to write that first. Then I'm going to combine negative 4x squared and 3x squared to make negative x squared. And then finally, positive 7 and positive 4 makes 11. So that's my answer. If you're asked for the degree of the polynomial, that just means what's the highest power of the polynomial. And if you're in standard form, that should be the first one. So this polynomial has a degree of 3. Okay, q of x minus p of x, same idea. Let's keep them both in parentheses. And if you remember, when you're subtracting things like this, it's really important that you distribute your subtraction sign, because the whole thing is getting subtracted. So usually what I'll do is I'll rewrite everything without the parentheses. This is going to be negative x cubed. The 4x squared actually becomes positive, and the 7 becomes negative. Now, just like before, I'll combine like terms. So yet again, my biggest exponent is the cube, and it doesn't have anybody to combine with, so I'm going to write that first. I'll combine my positive 3x squared and my positive 4x squared to make 7x squared. And then finally, my positive 4 and my negative 7 makes negative 3. So that's the answer. And then again, this is still going to be a degree 3 polynomial. Okay, multiplication now. So this time I'm doing r of x, which is x plus 3, times p of x. So x cubed minus 4x squared plus 7. Okay, so this is really just like double distributing, except one of your polynomials is a little bit longer, so you're still distributing everybody. So I would first distribute the x to everybody, and then the 3. So you should get 6 terms total. So x to x cubed gives me x to the 4th. X to negative 4x squared makes negative 4x cubed, and x to 7 just makes 7x. Now I start distributing the 3, so I start with 3x cubed minus 12x squared plus 21. And just like before, I'll just go ahead and combine like terms, putting them in descending order according to their exponents. X to the 4th in this case would be first. Then I can combine negative 4x cubed and 3x cubed, so that's negative x cubed. Negative 12x squared would come next. It doesn't have anyone to combine with. Then 7x, and then finally the 21. So there weren't a lot of like terms. I do, however, this time have a degree 4 polynomial because I multiplied, my powers went up. So that polynomial is degree 4. Okay, so finally we're going to do a division problem. Obviously I don't have space, so we'll go to the next page. Okay, so I'm dividing x cubed minus 4x squared plus 7 divided by, these dots never come out, x plus 3. Okay, so the first way that I'm going to show you how to do this is using what's called polynomial long division. It's just like the division you did when you were younger, except it's with algebra. So the x plus 3, that's our divisor, that goes on the outside of the house. And the longer one that you start with, that's called our dividend, that goes on the inside. There is one thing we have to watch out for with this polynomial. In a typical polynomial, you'd have an x cubed, an x squared, then you'd have an x, and then a number or a constant. We don't have that x, so it's actually really important with long division that you insert a little placeholder for anyone that's missing. So in this case, I need to put in a 0x. Okay, so that's our setup, and over here I'm just going to kind of do all the work that needs to be done in order to complete the problem. Keep everything separate. So I start by taking the first term of the dividend and dividing by the first term of the divisor. Okay, I'm really saying how many times does x go into x cubed? Well, it turns out that it's x squared times. So that's the first part of my answer, or my quotient. Now, if you remember, that needs to get distributed to the divisor. Again, I'll usually do that work over here to sort of keep everything neat. That gives me x cubed plus 3x squared. So that's going to go right under that other x cubed. However, if you remember from originally long dividing, several years ago, this is subtraction, so not only does the x cubed become negative, the 3x, that should be squared, it becomes a negative. So these cancel out, and this becomes negative 7x squared. Now I just keep dropping terms down and repeating the process. So now I'm taking negative 7x squared and dividing it by x. That gives me negative 7x, and that's going to be the next thing that I put on top. Now that gets distributed. So this process becomes pretty repetitive after a while. Negative 7x squared minus 21x. Okay, so again, that stacks right underneath my last step. And then I go and I change my sign. So this is really a positive in order for those to cancel. And this also changes to a positive. So now I have 21x. And finally I pull down that plus 7 and I repeat the process one more time. Once you're out of things to bring down, you'll know that you're finished. That positive 21 goes as the last piece of my quotient. Now that gets distributed. That'll give me 21x plus 63. Again, stack that right underneath your last, where you left off. Change your signs. So I'm doing 7 minus 63, which is negative 56. That, if you remember, is your remainder. So I'm finished. However, with a polynomial, I don't leave it like that. I write it out a little nicer than that. I'm going to change my color so it's easy for you to see. My final quotient or answer is x squared minus 7x plus 21, and I actually include the remainder, but what a remainder really is a portion of your divisor. So this is the proper way to write out your final answer. X squared, remember I had a little typo here, minus 7x plus 21 minus 56 over x plus 3. Okay, so that's the long way of doing it. There's another division method actually that you can use, so I'll just show you that quickly. It's much faster. Now I want to just kind of warn you, this method only works if your divisor starts out with just an x or a 1x. If you have any other number, any other slope really, since it's linear, you would not be able to do this method. I just want to make sure that's clear. So this method is called synthetic division, and it operates on the idea that if you have x plus 3 as a factor of a polynomial, that really means that the answer or one of the solutions to that polynomial would be negative 3. So that once you change that sign, that goes into the little sort of box that we use for synthetic division. And now I'm listing out all the coefficients of my dividend. Remember that whole missing term idea? I put in a 0 for where that x should have been. I leave myself some space, and now I start multiplying it. I'm really dividing, but you'll kind of see how this works. So the 1 drops down. Now I multiply the 1 times what's in the box, which is negative 3. Now I add straight down. That gives me negative 7. Negative 7 times negative 3 is positive 21. Adding straight down, I get 21. 21 times negative 3 is negative 63. And that gives me negative 56. These numbers should look really familiar to the numbers that we got in our answer on the last page. It's just a faster, more streamlined way of doing it. This really is my answer, but since it's a quotient, I put it back together. This is always my remainder. So your last number when you synthetically divide is your remainder. This would be your constant, or your number that doesn't have a variable. Then this is the x. This is the x squared, and if you kept going, you might have an x cubed, an x to the 4th. You always sort of work backwards to build your polynomial. So this answer, same as before, is x squared minus 7x plus 21, and then putting that remainder over your original divisor. So it's the exact same answer with really a lot less work, but you do have to understand how synthetic works and how it's set up. So 2 different ways to find the quotient. Just again, remember what we talked about, that you can only use synthetic division when your divisor has a slope of 1, meaning the coefficient in front of the x is a 1.